In the ongoing conflict between Russia and Ukraine, the Russian forces are using a deadly weapon, known as the vacuum bomb, against the Ukrainian forces. Unlike other bombs, the vacuum bomb, also known as the thermobaric bomb, is considered the most destructive non-nuclear weapon in the world. A weapon so deadly that it sucks the oxygen out of air, creates a temporary vacuum, and then explodes, vaporizing every living thing in its way, creating a powerful blast wave that can effortlessly destroy fortified positions. These thermobaric weapons are launched in the form of rockets, by a complex multi-barrel tracked vehicle system, known as the TOS-1A. Nicknamed the scorching sunlight, the vacuum bomb, when used on humans, is notoriously famous for rupturing internal organs such as the lungs, eardrums, inner ear, and brain tissue, also damaging the eyes and trachea, all while depriving oxygen from the target. In this video, with the help of 3D animation, we'll look at how the TOS-1A multi-barrel thermobaric rocket system works, in detail. This is the Soviet Union's TOS-1 Buratino, multiple thermobaric rocket launch system. It was designed in 1988 by Omsk Transmash Design Bureau. It could fire 3,220 mm rockets, and it first saw combat in the Soviet-Afghan War in 1988. In 2003, the Russian engineers designed the advanced version of the TOS-1 system, the TOS-1A. Nicknamed Solntsepyak, which translates to scorching sunlight, the Russian military calls it a heavy flamethrower system. The fully loaded TOS-1A has a mass of 4.53 tons. It's 9.5 meters long, 3.6 meters wide, and has a height of 2.2 meters. It has 3 crew members, the driver, the commander, and the gunner. Its operational range is around 340 miles, and has maximum speed of 37 miles per hour. It uses a V84 diesel engine that produces 840 horsepower. Unlike the Buratino, the TOS-1A carries 24 rockets only. These rockets are thermobaric weapons which are commonly known as vacuum bombs, aerosol bombs, or fuel-air explosives. These are 220 mm rockets, with effective firing range of 6.21 miles. The TOS-1A has 2 firing modes. In Mode 1, it fires 1 rocket at a time, and in Mode 2, it fires 2 rockets at a time. It can fire 4 rockets in 1 second. The TOS-1A has 2 sections. The launcher section at the top, and the chassis. The chassis was derived from the chassis of the famous Russian tank, the T-72. The chassis consists of the lower body, and the complete track system. 6 torsion bar sockets are attached to the lower body on either side. Next to the first, second, and sixth sockets, hydraulic shock absorbers are attached to the body. 6 rocker arms are attached to the sockets, and 3 of them are attached to the shock absorbers. Six wheels, known as road wheels, are attached to the rocker arms. The first, second, and the sixth wheels are now capable of absorbing heavy shocks and impacts. The forwardmost wheel is known as idler wheel. It is unpowered and is used to create tension to the track links to prevent the track from slacking. The last wheel is known as the drive sprocket. It is connected to the engine transmission, and it's the only powered wheel. It transmits torque to the track links to move the vehicle. They have teeth that acts like gear teeth, and they move the track links continuously. 3 return rollers are attached to the lower body. They are used to keep the track straight, that runs from the drive sprocket to the idler wheel. The tracks are assembled by connecting several individual track links. These links go around the wheels, making a closed chain, that are commonly known as continuous tracks. These individual links are usually made of steel plates, and are commonly used on robust and heavy military vehicles. The extruded structure in the middle of the link is known as the center guide. This guide goes in between the wheels and keeps the track in the center of the wheels. The links are held together with the help of pins. Now the links can move freely, like a hinge, allowing the track to make a continuous closed chain. Side skirts are attached on either side of the vehicle to protect the tracks and the lower body from enemy attacks as well as dust and debris. The forward-facing side skirts can be lifted up for maintenance purposes. In the front, at the bottom of the chassis, a hydraulically operated outrigger is installed. The outrigger, also known as dozer blade, is operated by the driver. It's used to clear out abrasive rocks, frozen soil, and to dig trenches very quickly. It's made of armor-grade steel, and it acts like an armor when it's not deployed. In the front, on the right side, there's the FG-125 infrared headlight. And on the left side, there's the FG-127 blackout light. The infrared light helps in navigating at night. Infrared light is invisible to naked eyes, but it can be detected by enemy night vision sights. The FG-127 blackout light emits a low beam light, just enough to see few meters in front of the vehicle. It's used during night convoys, to avoid being detected by the enemies. In front of the lights, a pair of towing cable holders are provided. They are provided at the back of the vehicle as well. Right behind the lights, there are smoke grenade dischargers. There are 4 smoke grenade dischargers, all facing forward. These are 902B smoke screen laying system that are used to conceal the vehicle's movement in areas of enemy fire. If the enemy spots the vehicle's position, the smoke grenades are launched and smoke screen is laid out. Now the vehicle can retreat before it's attacked.
If you are enjoying this video, subscribe to SYG Design Works for more advanced animations, and click on the bell icon to get notified when we upload a new video.
Behind the smoke grenade dischargers, there are convoy marker lights. There are a total of 7 convoy lights on the TOS-1A. 4 in the front, in which 2 are facing forward, and the other 2 facing sideways. There is 1 on the launcher section, and 2 near the rear end, all facing backwards. Convoy marker lights emit a very dim colored lights that can only be seen from a closer distance. They are used to tell the position and distance of the vehicle at night, especially during a convoy. The forward-facing lights are pale blue, or mint-colored. The sideways-facing lights are light yellowish in color, and all the rear-facing lights are red-colored. On the glacis plate of the vehicle, there's a V-shaped splash guard. Whenever the vehicle is moving in difficult terrain, the splash guard deflects water and mud away from the driver's view. Behind that, you can see the driver's hatch. This is where the driver enters the vehicle. Right in front of the driver, there's the driver's periscope. This is the TNPO-168B driver's periscope. It is most commonly used on the Russian T-72 and T-90 tanks. With the help of the periscope, the driver can see what's in front of him, without having to stick his head out of the vehicle. Weighing around 16 pounds, this periscope has 16 degrees field of view in the vertical plane, and 138 degrees in the horizontal plane. On the left-hand side of the vehicle, there are 5 boxes. These boxes are called tool stowage panniers. Tools for the repair and maintenance of the vehicle is stored in these boxes. Similarly, on the right-hand side of the vehicle, there are 5 compartments that stores fuel. These are external fuel cells that carries additional fuel, along with the vehicle's main fuel tanks, increasing the operational range of the vehicle. The turret is the heart and brain of the vehicle, and it's placed right in the middle of the lower body. It can rotate 360 degrees along the vertical axis, and it carries the commander and the gunner, along with all the necessary electronics required to detect and attack the target. The inner section is called the turret cabin. Seats for the commander and the gunner are placed here. A hydraulic cylinder is placed in between them. This cylinder tilts the launcher section up while firing the rockets. The bearing provides smooth rotation of the turret. This is the gunner's hatch. The gunner enters the vehicle here. Just like the driver, the gunner also has a periscope. This is the TNP-165A gunner's periscope. It provides 74 degrees of horizontal and 35 degrees of vertical field of view, and it weighs around 6.1 pounds. Right in front of the gunner, there's the 1D14-1 periscopic laser rangefinder. This is the gunner's main sight. It helps the gunner to determine the range of the targets, such as the tanks and other armored vehicles, at a distance of up to 6.21 miles, and bigger structures such as buildings and hills, at a distance of up to 15.5 miles. Once the target is located, the range data is generated. This range data is fed to the ballistic computer, which is on the left-hand side of the gunner. The ballistic computer generates the fire data. Fire data is nothing but the required azimuth and elevation angles required to precisely hit the target. The commander's hatch is where the commander enters the vehicle. The commander's main sight is the TKN-3MK thermal imaging observation device. This device can be used in daylight and night vision mode as well. It weighs around 27.5 pounds, has a horizontal field of view of 9.5 degrees in daylight conditions, and 7.75 degrees in night vision mode, and its night channel can operate in active and passive modes. This entire section is called Commander's Cupola. The commander can rotate it to get a better view of the target. The commander also has a periscope of his own. This is the TNPO-160 Commander's periscope. It has a horizontal field of view of 78 degrees and vertical field of view of 28 degrees, and it weighs around 7.5 pounds. The commander also has an infrared searchlight on the cupola. This is the OU-3GK Commander's infrared searchlight. It is used to search for the target at night. It has a 110-watt incandescent bulb in it. If the infrared filter is removed, it emits strong white light at 240 candela, and with the filter on, it emits a dim red light of 0.24 candela. On the right side of the turret, there's an antenna, which is used for communication purposes. Behind the turret, there's the engine compartment. The TOS-1A is powered by a powerful V84 diesel engine, which was mainly designed for the T-72 tanks. This is a 12-cylinder turbocharged engine that produces 840 horsepower. It weighs around 2,160 pounds, produces 3,483 Newton-meters of torque, has maximum fuel consumption of 260 gram per kilowatt-hour, at an RPM of 2,000. The engine's exhaust manifold is located on the left-hand side of the vehicle, and the smoke from the engine can be used to conceal the vehicle from enemy fire. Behind that is the radiator section, used to draw air to cool down the engine. Complex gear arrangements are used to transfer power from the engine shaft to the drive sprocket. That gearbox, or the transmission section, is located next to the radiator compartment. Two additional hydraulic cylinders are placed in the turret to help tilt the launcher section. The topmost section is the launcher section, also known as rocking unit. When not in use, this section is temporarily fixed to the lower body with two metal holders. The launcher section is attached to the turret and can rotate along the vertical axis of the vehicle. This is called finding the azimuth. 3 hydraulic cylinders tilt the launcher section up, along the lateral axis. This is called finding the elevation. With the correct azimuth and elevation angles, given in the fire data by the ballistic computer, the target can be hit with high precision. It carries 24 thermobaric rockets, and the launch tubes have a single barrel groove on the inside that spins the rockets for better stability. Unlike missiles, these are unguided projectiles and are therefore called rockets. This is the M04M 220mm thermobaric rocket. It is 12.2 feet in length, weighs 478 pounds, with an effective firing range of 6.2 miles. The forwardmost section of this rocket has an impact fuse, which is connected to a bursting charge. The bursting charge runs through the thermobaric warhead. This warhead is usually made of a single compound, and they are used in the form of gas, liquid, or powder. This warhead is a powdered explosive and it does not contain an oxidizer, meaning it draws oxygen from the surrounding air to burn. This rocket uses a solid rocket motor for propulsion. An electric flash fuse is used to ignite the rocket motor. All of these are placed inside the rocket's thin outer casing. The rearmost section has 4 deployable fins. They keep the rocket stable throughout the flight. These weapons are very effective against fortified positions such as bunkers, trenches, and foxholes. This is an underground bunker, made of thick wall of concrete, strong enough to withstand enemy fire and harsh weather conditions. They usually have a small chamber inside them, with few operators, and they have radio equipment, food, and even some bed for the operators. With the help of the commander's main sight, the commander identifies and locates the target. He communicates with the other TOS-1A commanders, and then gives orders to his driver to move the vehicle to a location that is both safe and within the firing range of the rockets. Once the vehicle is positioned at the right place, the hydraulic locks are deployed. These locks keeps the vehicle stable while launching the rockets. Then the gunner, with the help of ballistic computer, generates the fire data that gives the correct azimuth and elevation angles. And then, the attack begins. The target is bombarded with thermobaric rockets. When the rocket hits the target, the impact fuse activates, and the bursting charge detonates. This charge bursts open the outer casing of the rocket, and the powdered fuel warhead is dispersed. This fuel cloud goes into every openings, cracks, and perforations of the bunker, and also into the lungs of the occupants if inhaled. Fraction of a second later, the fuel cloud is ignited. It draws oxygen from the surrounding air, and explodes, reaching temperatures up to 5,430 degrees Fahrenheit. The overpressure created during the explosion obliterates everything in its way, while vaporizing it. When the gas is cool, the pressure suddenly drops, creating partial vacuum that damages most of the internal organs of the victims, and the gases produced after the explosion are highly toxic. Since the weapon is heavily dependent on the atmospheric air for combustion, they are unsuitable for use at high altitudes, underwater, and adverse weather conditions. According to International Review of the Red Cross, the use of thermobaric weapons is not illegal, as long as they are used to protect the civilians and civilian objects. So far, all attempts to regulate or restrict thermobaric weapons have failed. This is how the deadly TOS-1A vacuum bomb system works. Thank you for watching.